Hello everyone, welcome back to my channel. In this video, I am going to talk about NE555 timer IC. It is a very familiar IC, which can be used in variety of application, such as timer, oscillators, pulse generator, etc. In this video we will discuss three modes of operations: monostable mode, astable mode, and bistable mode. So let's get started. First let's identify the pinout of the IC. Pin 1 and 8 are the power supply pins. Pin 1 is negative, and pin 8 is positive. The supply voltage is in between 4.5 volt to 15 volt. Pin 2 is the trigger input pin. A low voltage supply is applied to the trigger input causes the output to go high. The output will remain high until a high voltage is applied to the threshold input. Pin 6 is the threshold input pin. During the operation of astable and monostable mode, the voltage across the timing capacitor is monitored through the threshold input. When the voltage at this input rises above the threshold value, the output will go from high to low. Pin 3 is the output. In output low state the voltage will be close to 0 volt, and in output high state the voltage will be 1.7 volt, lower than the supply voltage. The maximum output current is only up to 200 milliamperes. Pin 7 is the discharge output. When the voltage across the timing capacitor exceeds the threshold value, the timing capacitor is discharged through this pin. Pin 4 is reset input. A low voltage is applied to the reset pin will cause the output pin 3 to go low. This input should remain connected to VCC when not used. Pin 5 is the control voltage pin. It uses to control the threshold voltage on pin number 6 through the control input. When not in use, it is recommended to connect it to ground via a 0.01 microfarad capacitor. Now let's check the circuit diagrams of different operation modes. Here is the circuit diagram of monostable mode. Here we can see an LED is connected at the output pin. When we power on the circuit, there will be no output at pin number 3, the output will be 0. When we press the push button, which is connected from pin number 2 to ground, then the LED will turns on, and stays on for a few seconds. After a few seconds it turns off. Again, if we press the push button the process repeats. Now let's check the practical circuit on the breadboard. When I press the push button, the LED illuminates. But it only lasts for a few seconds. By changing the values of resistor R2 and capacitor C1, the output values can be increased or decreased accordingly. Here, R2 is 50 k ohm, and C1 is 10 MFD. I am changing R2 with 150 k ohm, and C1 with 33 MFD. Now let's check the output. The LED is on now, and it stays on for a long time than before. Now let's replace R2 with a potentiometer, and C1 with a 100 UF capacitor, and then check the output. Here I replaced R2 with a potentiometer, and C1 is replaced with 100 MFD capacitor. Now, we can adjust the on-off time intervals of the LED by rotating the potentiometer. In this mode of operation, the IC works as a timer switch. This is the circuit diagram of another mode of operation, which is called bistable mode. In this mode of operation, the output of the IC has two stable states, either on or off. In the circuit, we can see two switches connected with the IC, S1 and S2. S1 is connected with pin number 2 to ground, and S2 is connected with pin number 4 to ground. When we power on the circuit, the output of the IC will be 0, there is no changes at the output. But if we press S1, the output of the IC will go high, and the LED will turn on, and it keeps on, until we press S2. Here is the setup of the bistable mode. These are the push buttons, which are mentioned on the circuit diagram. One is connected from pin number 2 to ground, and another one is connected from pin number 4 to ground. As we can see, the LED turns on when I press S1, and turns off when I press S2. Finally, the last mode of operation of this IC is an astable multivibrator, or we can say, an oscillator. It generates a square wave output, which means the output of the IC continuously varying on and off without any external trigger. Let's test the circuit. When I connected the power supply, the LED starts to blinking. The frequency of the oscillation can be changed by changing the values of R1, R2, and C1. Here is the equation for calculating the frequency. If you found the video helpful, please consider subscribing to my channel. Thank you for watching.